Hi everyone. In today's class, we are going to discuss how to improve the power factor in a three-phase circuit. Objective: at the end of this video, you will be able to connect the capacitor bank to an inductive load and measure the power factor. Calculate and record the improvement in power factor after connecting the capacitor bank. Let us discuss the power factor. The power factor is a ratio of electrical power that indicates how much power is utilized by the load in watts for the given input power VA. Power factor is equal to W by VA. Power factor correction is very important in any electrical system because a low power factor can lead to higher electricity bills or penalties, less power from the electrical system, and more losses in the way of electricity is sent and used. It can be done by moving the phase of the current so that it is in phase with the voltage. It is very important to maintain the power factor at 1 or unity so that input power VA is totally utilized by load W without any loss. When the load is an AC motor inductive load, the power factor will not be unity due to the reactive power which is considered as loss. So, by reducing the reactive power, the loss can be reduced, thereby the power factor can be improved to unity. There are different methods to improve the power factor, but the most common method is by using a capacitor in parallel with the inductive load. Let us discuss this in practical terms. Let's collect the instruments and materials required. 3-phase squirrel cage induction motor, 3 HP, 415 volts with load arrangement 1 number. Capacitor bank, 3-phase, 415 volts, 1.5 kVAR, 1 number. 3-phase power factor meter, 415 volts, 20 amps, 1 number. Wattmeter, 500 volts, 10 amps, 2 numbers. Moving iron ammeter, 10 amps, 1 number. Moving iron voltmeter, 300 volt by 600 volt, 1 number. 4-pole MCB, 16 amps, 1 number. Insulated copper wire, 2.5 square millimeter, 20 meters. Connect the ammeter, voltmeter, wattmeter, and power factor meter to the 3-phase induction motor as given in the circuit diagram. Connect the circuit to the 3-phase supply through a 4-pole MCB. Switch on the power supply. Apply the load for 60% and note down the meter readings in the tabulation. Decrease the load on the motor and switch off the power supply. Connect the 3-phase capacitor in parallel to the 3-phase supply as shown in the circuit diagram. Switch on the power supply. Apply the same 60% load to the motor and note the meter readings in the tabulation. Compare the power factor noted before and after the capacitor bank connection. You could observe an improvement in the power factor. Let us calculate the power factor using the formula and compare it with the measured readings from the power factor meter. Power factor before the capacitor connection. Substitute the values of the wattmeter, ammeter, and voltmeter readings in the formula. Cos pi is equal to W1 plus W2 by 1.732 into VL into LL. Compare this calculated value with corresponding power factor meter readings and ensure both are the same. Calculate the power factor using wattmeter readings after the capacitor bank is connected and compare it with the corresponding power factor meter readings. Verify the power factor is improved after the capacitor bank is connected in parallel to the circuit. I hope after watching this video, you will be able to understand how to improve the power factor by using a capacitor bank in a three-phase circuit. Thank you. Have a wonderful day.